Hi everyone, my name is Sharon Vijayanand and I am a second year graduate student at Mercer University College of Pharmacy. Today I will be presenting my poster titled The Microneedle Approach for a Virus-like Particle-Based Microparticulate Flu Vaccine. The main purpose of our project was to formulate and test a microparticulate vaccine for influenza. And this vaccine holds M2E virus-like particles, the matrix ectodomain of the influenza virus. And the vaccine particles were incorporated into pain-free dissolving microneedle patches. For the formulation, we used polylactic glycolic acid, which is a FDA-approved biodegradable polymer. Once the particles were formulated, we then tested them in vitro using cell-based assays, followed by which we tested the vaccine in vivo to test their immunogenicity as well. The vaccine was formulated using a double emulsion method. It was characterized for various parameters such as size, shape, charge, encapsulation efficiency, etc. For the in vitro cell-based assays, we did a nitrite release, which tested the innate immune response using a cell-based assay. We then tested the antigen presentation capacity of the vaccine, where we quantified the major histocompatibility complex 1, 2, and their co-stimulatory molecules on the surface of dendritic cells. Once this was done, we then moved on for the in vivo immunization in mice using the vaccine microneedle patches. Once the vaccine particles were formulated, we did some characterization tests. The yield was quite high. The size was less than 900 nanometer, which was very pleasing to us. The zeta potential indicated that the vaccine is stable in the solution form. The encapsulation efficiency was 88%, which was also promising as well. When we looked at the nitrite release, we could see that the particles with or without the adjuvant could induce an excellent nitrite release when compared to just the suspension group. Similarly, for the co-expression of the MHC1, 2, and their co-stimulatory molecules, we found that compared to the suspension group, the vaccine microparticles and the particles with the adjuvant group did show a significantly higher response. We then moved on to the in vivo immunization, and then we tested the mice sera for the IgG levels. We found that the vaccine and vaccine plus adjuvant groups did have a significantly higher IgG level when compared to just the suspension groups and for week 4 and week 7. We then looked at the CD4 and CD8 expression in spleen and lymph node. The data for spleen is shown over here. As you can see, the particles and particles plus adjuvant groups did show a significantly higher response than the suspension group. IgG, we then tested the IgG subtypes for IgG1 and IgG2A, which is indicative of the Th1 and Th2 type immune response. We did find that the microparticulate vaccine was able to induce a significantly higher response when compared to the suspension group for both these subtypes. We then concluded that the vaccine had excellent potential. It induced an excellent innate immune response. It had increased expression of antigen presenting molecules, and the in vivo immunization results were also promising. It had an effective humoral response as well as a cell-mediated response. Moreover, in the current scenario, microneedles are an effective approach because this can be promoted as self-administration process. They also are greatly patient compliant, and particularly for toddlers and children. Yes, microneedle is definitely an attractive option for this kind of immunization during COVID. The further studies that we're planning to do is to test the cross protectiveness of the vaccine and also to do some neutralization assays. Thank you.